I'm going to show you how to calculate drug dose based on body surface area, and we are starting right now. Hello, this is Dr. Dankwa, and if this is your first time here and you like to learn pharmaceutical calculations, tips, tricks, and strategies, then start by subscribing and clicking the bell so you don't miss anything. So in this tutorial, I'm going to give a brief overview on why body surface area is important when it comes to drug dose calculations. We then go ahead and look at how you actually determine or calculate the body surface area with some examples, and then we'll finish off with 4 carefully selected examples illustrating some of the various ways in which you would encounter drug dose calculations based on body surface area. So let's get right to it. When it comes to selecting the appropriate dose of medication for a patient, normally the indication of the medication provides sufficient information on how much to give the patient. So for example, the adult dose for acetaminophen is 650 milligrams every 4 to 6 hours. So this would be appropriate for most people. There are, however, some drugs which are actually dosed based on the body weight. And I do have a video on calculating drug dose based on body weight, so I'll put a link in the description and the card should pop up pretty shortly. However, there are some therapeutic agents, especially those with significant toxicities, which are best dosed on the body surface area. And the reason is that calculating drug dose based on body surface area has been shown to give the best dose-response relationship for these therapeutic drugs. Now, the body surface area method of calculating drug doses is best suited for 2 scenarios. The first being chemotherapy, where cancer patients received antineoplastics, and the second is for pediatric patients. Now, the body surface area is expressed as meters squared, and the normalized dose would then be given typically as milligrams per meter squared. So anytime you see the meter squared in the denominator, that will be a dose that has been normalized to the body surface area. There are 2 ways in which you can calculate the body surface area. The first one is using an equation, and there are about 19 different types of equations that can be used for calculating the body surface area. The more common ones are the Mosteller method and the Dubois method. Now, out of these 2, the Mosteller method is more commonly used because the Dubois method has been shown to underestimate the body surface area when it comes to pediatric patients. So aside the equation, the other way you could calculate the body surface area is to use nomogram, and we'll take a look at how you calculate the BSA using equations and nomograms in this particular tutorial. So now the last point I'd like you to have stenciled on your mind from this brief overview is that for an average size adult, the BSA is 1.73 meters squared. So now let's go ahead and take a look at how you calculate the body surface area using the equation method. And so the equation we want to focus on is the Mosteller method, and the equation says that BSA in meters squared is equal to the square root of the patient's height in centimeters times the patient's weight in kilograms divided by 3600. Now the 3600 is an empirically determined constant. And this number, although the units are not given in the equation, actually has units of centimeter kilogram per meters to the power 4. Now, this is one form of the equation. There is an alternative form, and that is given as BSA in meters squared is equal to the square root of the patient's height in inches times the patient's weight in pounds divided by 3131. Once again, the 3131 is an empirically determined constant, and in this scenario has units of inches pounds per meters to the power 4. So you have 2 forms of the equation, and my recommendation is for you to use the equation that allows you to get the BSA in the most expeditious manner based on the patient information provided. So now let's take a look at some examples and see how to do that. In example 1, the question says calculate the body surface area for a patient who weighs 70 kilograms and is 167.6 centimeter tall. So based on the height, which is in centimeters, and the weight, which is in kilograms, the most appropriate form of the equation to use would be BSA in meters squared being equal to the square root of the patient's height in centimeter times the patient's weight in kilograms divided by the 3600, because the units in the equation are the same as the units for the patient information provided. So now we can go ahead and simply substitute the values of the patient's height and the patient's weight into the equation. So now we have BSA in meters squared being equal to 167.6 times 70 divided by 3600. This breaks down to give us square root of 11,732 divided by 3600. And so the BSA in meters squared is going to be equal to square root of 3.259, and that should give us 1.81 meters squared. Let's take a look at another example. So this question says calculate the body surface area for a patient who weighs 144 pounds and is 68 inches tall. Now, based on the patient information provided, the most appropriate form of the Mosteller equation to use would be BSA in meters squared being equal to the square root of patient's height in inches times the patient's weight in pounds divided by 3131. And the reason being, once again, that the units that we have in the equation match exactly with the units of the patient information provided. So that would allow us to determine the BSA very quickly. So we go ahead and determine BSA in meters squared, which is going to be equal to the square root of 68, which is the patient's height, times 144 pounds, which is the patient weight, divided by 3131. And that should be equal to the square root of 9,792 divided by 3131. And that implies that the BSA in meters squared is going to be equal to the square root of 3.127, and that should be equal to 1.77 meters squared. Now let's take a look at another example. And in this example, the question says calculate the body surface area for a patient who weighs 180 pounds and is 6 feet 3 inches tall. So now the question becomes, which form of the Mosteller equation do you use here? Now you could use either form of the equation, but my recommendation, especially if you want to determine the BSA expeditiously, is to use the version of the equation in which the units of the patient's weight matches the units of the patient's weight given in the question. So for this scenario to be the one where you have patient's weight in pounds and height in inches. So what that will mean then is we need to convert the 6 feet 3 inches to inches before we can proceed with that equation. So we do a quick conversion. For 6 feet, if we want to convert that to inches, we need to use the conversion factor where 1 feet contains 12 inches. So the feet cancel out and you end up with 72 inches. But you don't stop here because the patient is 6 feet 3 inches tall. So we need to add 3 inches to that. So the patient's height will be 72 inches plus the 3 inches, which gives us 75 inches. So now we go ahead and we put that in this equation, which is the BSA meters squared is equal to patient's height in inches times the patient's weight in pounds divided by 3131. So now we go ahead and substitute the information into the equation. So BSA in meters squared is going to be equal to the square root of 75, which was the patient's height in inches, which we just calculated, times the 180 pounds, which is the patient's weight, divided by 3131. This should give us the square root of 13,500 divided by 3131, which should then give us BSA in meters squared being equal to the square root of 4.312, and that is actually equal to 2.08 meters squared. So by using this form of the equation, we actually arrived at the BSA in about 5 steps. So now let's take a look at the next example, which actually is the same question we just looked at in this example, but we are going to use the other version of the Mosteller equation. So the question once again says calculate the body surface area for a patient who weighs 180 pounds and is 6 feet 3 inches tall. So for the other version of the Mosteller equation, we need patient's height to be in centimeters and patient's weight to be in kilograms. So we actually need to convert the 6 feet 3 inches into centimeters. So the 6 feet, if you want to convert that into inches, is going to be 1 foot contains 12 inches, which gives us 72 inches. We then go ahead and add the 3 inches to that. So we have 72 inches plus 3 inches. That gives us 75 inches. We now need to convert the 75 inches into centimeters. So we have 75 inches. We multiply that by the conversion factor, where 1 inch is equivalent to 2.54 centimeters. The inches cancel out, and you end up with 190.5 centimeters. And so the patient's height is 190.5 centimeters. We now need to convert the weight from pounds to kilograms. So we take the 180 pounds, we multiply that by the conversion factor, which says 2.2 pounds is equivalent to 1 kilogram. The pounds cancel out, and you end up with 81.82 kilograms. And so the patient's weight is 81.82 kilograms. So now we can go ahead and substitute the patient's height in centimeters and the patient's weight in kilograms into the Mosteller equation. So patient's height is 190.5 centimeters. The patient's weight is 81.82 kilograms. And so now we use the equation which says BSA in meters squared is equal to the square root of patient's height in centimeters times patient's weight in kilograms divided by 3600. So we go ahead and put in the values into the equation. So BSA in meters squared is equal to the square root of 190.5 times 81.82, which is the patient's weight in kilograms, divided by 3600. This should be equal to the square root of 15,586.71 divided by 3600, which implies that the BSA in meters squared is equal to the square root of 4.330, and that should be equal to 2.08 meters squared. So we notice that the BSA is 2.08 meters squared regardless of the version of the Mosteller equation used. However, if we compare the number of steps it took to get to the answer, we will notice that it took us about 5 steps when we used the version that had patient's height in inches and weight in pounds, compared to about 7 steps where the patient's height was in centimeters and the patient's weight was in kilograms. So you could use either version of the Mosteller equation to determine the BSA. However, if speed is of importance to you, you want to be strategic in the version that you select so that you can arrive at your answer expeditiously. So we talked about how you can use the equation to determine BSA. Now let's take a look at how you can use nomograms, because every now and then you may be required to use the nomogram to calculate the body surface area of a patient. So the nomogram is a graphical representation of one of the equations that have been empirically developed to determine body surface area. So a nomogram has 3 columns. The first is height, which is expressed in centimeters and in inches. The second is the body surface area expressed in meters squared or square meters. And the third is weight expressed in kilograms and in pounds. So how do you use the nomogram? You need to know the patient's height, and then you mark that on the nomogram, and then you need to know the patient's weight. You also mark that on the nomogram, and then you draw a straight line connecting the height and then the weight, and then where the line intersects the BSA column, that will be the BSA or the body surface area of the patient. So let's see what all of this looks like practically speaking. This is how your nomogram looks like. The height is in the left column, and you notice that you have units of centimeters on the left side and units of inches on the right side. Then the body surface area is right down the middle with units in meters squared. And then you have the patient's weight, which is the column to the right, and it has units of pounds on the outer side and units of kilograms on the inner side. So now let's take a look at an example of how you can use the nomogram to calculate the body surface area for a patient. So here the question says calculate the body surface area for a patient who weighs 170 pounds and is 181 centimeters tall. And so the first thing we need is the patient's height, which is 181 centimeters. And then we also need the patient's weight, which is 170 pounds. So we go to the nomogram and then we look for the height column, which will be the column to the left. And because the units of the patient's height are in centimeters, we are looking to the left side of that column. So we look for the 181 centimeters and we indicate that on the chart. So we have that indicated by the red dot. And now we go to the weight column, which is the column on the right hand side, and we have the patient's weight to be 170 pounds. So on the weight column, we're also going to look on the right hand side of that column, which is where the pounds units are. And so we look for 170 and then we mark that on the nomogram. We just did that with a dot. And now what we do is we connect those two dots indicating the height and the weight with a straight line. And where that straight line crosses the body surface area column, which is the column in the middle, that will give us the body surface area. So here we see that where it crosses the body surface area is just indicated with a red dot, and that gives us the BSA, which should be 1.97 meters squared. So now let's take a look at another example which says calculate the body surface area for a patient who weighs 118 kilograms and is 5 feet 8 inches tall. So we have the patient's weight in kilograms, but then the height is in feet and inches. And in the nomogram, there's no feet on there. So the first thing that we need to do is convert the height from feet and inches into inches. So we'll take the 5 feet and we'll convert that to inches using the conversion factor that 1 feet is equivalent to 12 inches. The feet cancel out and we end up with 60 inches. But we don't stop here because we have 5 feet 8 inches. So the patient's height is actually going to be equal to the 60 inches plus the 8 inches, and that gives us 68 inches. So now we can go ahead and use the nomogram. So we have the patient's height to be 68 inches, and then the patient's weight is 118 kilograms. So we have the patient's height to be 68 inches. We go to the height column, which is the column on the left, and we locate 68 inches, which would be on the inner side of that column. So we locate 68 inches and we indicate that with a dot. And then we go to the weight column, which is the column on the right hand side, and we locate 118 kilograms. So the kilogram portion is on the inner side of the column. And so we look for 118 and then we indicate that with a dot. So now the next thing that we need to do is draw a straight line that connects those two dots, and wherever the straight line intersects the body surface area column, that will be the BSA. So we can indicate that also with another dot, and our BSA is equal to 2.28 meters squared. So now let's take a look at another example. In the previous two examples that we just looked at, the question was more focused on an adult patient. So let's see how it looks like if you do have an adolescent patient. And so here the question says calculate the body surface area for an adolescent patient who weighs 90 pounds and is 50 inches tall. And so the patient's height is 50 inches and the patient's weight is 90 pounds. And so the first thing that we do is we take the 50 inches and we try and locate that on the height column, which will be the column to the left. And since we are looking for the patient's height in inches, it's actually on the inner portion of the height column. So we look for 50 inches and we indicate that with a dot. And then we take the patient's weight, which is 90 pounds, and we go to the weight column, which is the column on the right hand side. And since the patient's weight is in pounds, it's actually going to be on the outer side, on the right hand side of the weight column. So we locate 90 pounds and we indicate that with a dot as well. So now we connect those two dots with a straight line, and wherever the straight line intersects the body surface area, which is the column in the middle, that will be the body surface area. And so we can indicate that point of intersection with the dot. And so the body surface area is going to be equal to 1.16 meters squared. So we looked at how to calculate the body surface area using the Mosteller equation and using nomograms. Now let's switch screens and we're going to take a look at 4 strategically selected examples of calculating drug dose based on body surface area. So let's take a look at this question, which says a patient's weight is 70 kilograms and height is 155 centimeters. Calculate the dose of fluorouracil in milligrams for the patient if the oncologist orders 400 milligrams per meter squared daily. So let's quickly analyze this question. What we have is a normalized dose of 400 milligrams per meter squared. So since it is per meter squared, means this dose has been normalized to body surface area. And so we need to look out from the question for body surface area information. Now, since that is not given us directly, we take a look at the patient's information and we see that we have a height of 155 centimeters and a weight of 70 kilograms. So because the units of weight is kilograms and the units of the height is centimeters, we will use this version of the Mosteller equation. And that version will be your body surface area, BSA, is equal to the square root of the height in centimeters times the weight in kilograms divided by 3600. And so we will go ahead and put that information into the equation. So we have the square root of the height, which will be 155, times the weight, which will be 70, divided by the 3600. And so that is going to be equal to the square root of 3.014. And so the BSA is going to be equal to 1.74 meters squared. But we don't stop here. So what we now do is we take the normalized dose, which is the 400 milligrams per meter squared, and we multiply that by the body surface area, which is the 1.74 meters squared. So the meter squares cancel out and you end up having 696 milligrams. Let's take a look at another example. So this question says DD is a 20-year-old male who takes phenytoin 150 milligrams per meter squared twice daily for seizures. DD has a BSA of 1.1 and the units should be meter squared. Phenytoin comes in 50 milligrams per 5 ml. How many milliliters will DD need for his daily dose? So let's quickly analyze this question. We have a normalized dose for phenytoin of 150 milligrams per meter squared, and that is given twice daily. Because it's normalized to body surface area, we need some body surface area information, and that is given us in the question explicitly. So that would be the 1.1 meter squared. So what we need to do is make sure we know what the daily dose is for DD. Because we have been given 150 milligrams per meter squared for each dose. And now DD takes 2 doses every day. So now the doses can cancel out, and what we actually have is 300 milligrams per meter squared every single day. And so this implies that the daily dose is actually going to be 300 milligrams per meter squared. So now what we need to do is actually make use of the daily dose, which is a normalized dose, and find out exactly how many milligrams DD gets. And to do that, we'll take the daily dose, which is the 300 milligrams per meter squared, and we will multiply that by the body surface area, which is 1.1 meter squared. The meter squares cancel out, and you end up with 330 milligrams of phenytoin. But the question is asking for quantity in milliliters, and so we make use of the concentration, which would be 50 milligrams of phenytoin is present in 5 milliliters. that should be equal to 330 milligrams divided by some volume, which should be x ml. So we go ahead and solve for x, which is our unknown. X equals 5 milliliters times 330 milligrams divided by 50 milligrams. And so x equals 33 milliliters. Let's take a look at another example which says the drug carboplatin for ovarian carcinoma is administered intravenously at a dose of 360 milligrams per meter squared, except in patients with impaired kidney function, in which case the dose is reduced by 30%. How many milligrams of the drug should be administered to a renally impaired patient measuring 5 feet 2 inches and weighing 110 pounds? So let's analyze this question. We have a normalized dose of 360 milligrams per meter squared, but this patient has impaired kidney function, and so the dose is reduced by 30%. So we need to account for that as we solve this particular question. But because it's normalized to meter squared, which is body surface area, we need BSA or body surface area information. And since that is not given us directly, we make use of the patient information. We have weight of 110 pounds and height of 5 feet 2 inches. So since we have the patient's weight in pounds, so the most appropriate form of the equation that we will use is BSA is equal to the square root of height in inches times the weight in pounds divided by 31. Now the weight is already in pounds, and that's why we are using this form of the equation, but we need to convert the height to inches. So for patient's height, we will have 5 feet, and we'll convert that to inches using the conversion factor. 1 foot is equivalent to 12 inches. The feet cancel out, and you end up with 60 inches. But now we don't stop there. We add the 2 inches because the patient is 5 foot 2 inches. So plus 2 inches, and that gives us 62 inches. So now we can go ahead and plug the information into the equation. So BSA is going to be equal to the square root of 62 times 110 divided by 31, and that should be equal to the square root of 6820 divided by 31, which is equal to the square root of 2.178, which is equal to 1.48 meters squared. So now we have the body surface area. The next thing we want to do is actually determine the normalized dose for this particular patient. So we will take the 360 milligrams per meter squared, and we need to adjust this because the patient has impaired kidney function. And so since that is reduced by 30%, it means we need to give 70% of the actual dose. And now 70 divided by 100 is going to be equal to 0.7. So we can multiply the normalized dose by 0.7, and that should be equal to 252 milligrams per meter squared. So to determine the actual dose, we'll take the normalized dose, which is a 252 milligrams per meter squared, and multiply that by the body surface area, which is the 1.48 meter squared, and that should be equal to 372.96 milligrams. Let's take a look at another example which says a patient is at the clinic to get his round of chemotherapy. His medication is dosed at 110 milligrams per meter squared over 4 hours. How much of the drug in milligrams is the patient getting every hour if his BSA is 1.9 meters squared? So let's analyze the question. We have a dose of 110 milligrams per meter squared over 4 hours. So that is given over 4 hours. And because it's normalized to meter squared, which is body surface area, we need to make sure we have BSA or body surface area information. And now the question actually tells us that his BSA is 1.9 meters squared. So we don't need to calculate the BSA here. But what we need to do is we need to take the 110 milligrams per meter squared, which is given over 4 hours, and determine what it will be for 1 hour. So we multiply that by 1 hour, the hour cancels out, and that actually gives us 27.5 milligrams per meter squared. So we can go ahead and find the amount in milligrams that the patient is getting by taking the 27.5 milligrams per meter squared and multiplying that by the body surface area, which is 1.9 meters squared. So the meter squares cancel out, and we end up with 52.25 milligrams. So I hope you found this tutorial useful. If you did, be sure to like it and share it. And if you have any questions, put them in the comments and I'll get to them as soon as I see them. If you'd like to learn more pharmaceutical calculations, tips, tricks, and strategies, then don't forget to subscribe and click the notification bell so you don't miss anything. Thank you so much for watching, and I will see you in the next video.